what these systems are actually measuring well. So let's stay there for a moment. What types of data are proving most predictive right now? Language, behavior, biometric signals, or something else? And where are you seeing the strongest signal?
I guess the question even not is what is more predictive, but what do we have enough to even start building AI? So the predictivity level can be identified by two things. Like first is a signal to noise ratio. So understand what is a strong signal, how meaningful is that, and how powerful is it in order to predict it. And the second part is a quantity, because sometimes the quantity can help us to cover the issues with the noise. And that's why we can use different types of data, right? It can be behavioral, like, for example, the way how you act on Amazon, like what music you're listening to on like Spotify, what TV shows you're watching Netflix, and all your patterns. And because we have a lot of data, it is already highly predictive compared to biological, which we don't have enough amount. So I would say there is like no difference in the data that we're using. It's just more about what can come first, and it will depend on availability. So that's why I expect that the first predictive models will be using language, they will be using facial expression, they're going to be using like conversation, tone of voice, behavioral patterns, etc. But on the biological side, I truly believe that there is a lot of more meaningful signal that can actually uncover the phenotypes that we discussed earlier. But there is a complexity on how can we collect the data that's going to represent healthy population, that's going to represent population with the disorders. How can we going to set labels? And that's why it's not that it's low predictive value in this data, but it's just like harder to build AI in the space of biological data.